I'm gonna forget because I'm always trying to remember to hit record. So, all right, we are live now. We're recording. So from now on, things are gonna go to YouTube. So hello, people from the future watching this on YouTube. Um, I just I was just about to say that I have this feeling that we don't have much content being created in type theory in programming languages. Like you go to YouTube and all you'll find is like talks from conferences or best case scenario, like some presentation of papers and things like that. There's there's not too many things there. There are a few podcasts. There is the Church of Logic from Cody Rule, which is amazing. Really, really cool guy, incredibly smart guy. There is Type Theory Commute and from Aaron Stump, which is absolutely incredible. He records on his car though, so sound quality is not the best, but the content is absolutely the best. It's the best content you can get in this stuff, for sure. Um, and I think Jane Street had a podcast on type theory and programming languages at some point. I don't know how that is going. Cyril Cal had a podcast at some point. Galois had a podcast at some point. All of those come and go. There is a dad podcast called the Type Theory Podcast, which the author of this book we're looking at here is one of the hosts of that podcast, and is the reason why Type Theory for All is not called the Type Theory Podcast, is because it already exists and it's incredible. It's really good. It's also with John Sterling, one of Bob Harper's students, which is just an incredible beast. Like he's extremely smart. Yeah. Um, I think originally he's not even a computer science major. I think he was like a philosophy major or something, and then he does this incredible PL stuff. Yeah, one of our chat agrees. John Sterling is absolutely amazing. I thought it was really funny because once he finished his PhD, he started posting. Well, when he was about to finish his PhD, he started posting on Twitter a lot of stuff, a lot of hot takes. He grew, and like a lot of followers there, and then he got tenure and disappeared. It doesn't. I've never seen him on Twitter anymore, which I find funny. But man, I have to be careful. I have to be careful because I'm really bad at I don't know, like when you're online, you have to be careful so people don't think you're not canceled kind of thing, like, or I don't speak things that can go different ways. So um I think John is incredible. David Christiansen is absolutely incredible. I had a lot of fun talking to him. So another thing that I was mentioning is that I totally forgot what I went to the in this place. So yeah, right. So what I was gonna say is that the conversation I had with David was really cool. Great David Christiansen. We had 2 episodes with him, around a little less than 2 hours each, uh, and it was really fun, really cool. And one thing that we're talking last time is that um, he actually developed his own tool to write this book um, for Lean. So I forgot the name of the tool, but yeah, it's a tool he made himself. Well, I think that's what I had to share. One thing that I was showing before I started recording is that we have a type theory marketplace now, which I'm extremely excited because it was literally just released, and we have some really cool merchant going on over there. We have this hoodie with oh, oh, here it is, with the lambda cube, which I find very full, very fun, very cool. And there is a black version as well, which I find to be very good looking. So go there, check it out. We have this well-typed programs cannot go wrong shirt. We have Hilbert, like friend style cool PL people shirt. So check that out. I'll probably also release some discount codes. So on YouTube, check the description how much discount we're giving. Use the discount codes there. So yeah, exciting. Okay, so with those things out of the way, chat, feel free to say anything, to ask questions. Otherwise, I'll go ahead and continue from where we stopped on Tuesday. So as a reminder, Lean studying groups are Tuesday and Thursdays. Today's a Thursday, around 2 or 3 p.m. in Brazil time, which is GMT -3. So we have a schedule on Twitch. Make sure to follow and do all those cool things you do on Twitch. If the chat could check for me if the description today is correct. Tuesday the description was wrong because we're also running the Rock learning group, which are Monday and Wednesdays. So last time I was using Rock's definitions. So I want to make sure I got things right this time. Oh yeah, so I got a confirmation from chat. Thank you. Today the description is correct. Okay, let's see what we've got for today in Lean. One thing that I was definitely doing last time is, like doing a little bit of giving some thoughts and giving a little bit of comparison because between Lean and Rock as we go, like thinking of what are my expectations or what I would have expected from a Rock background. By the way, Coq just changed the name to Rock, so huge win to the community, I think. I'm trying to get the Rock's developers to come over to the podcast so we can talk about it. So that's in the talks behind the scenes. And what I was gonna say is that Tuesday, like I was making some comments and giving you my expectations. I have around 10 years of experience using Rock. I did my master's using some really bare bones, low level Rock and tactics. By no means I'm the most knowledgeable person in Rock, but I know some things. I'm confident enough with my knowledge to kind of like teach a course, like, or at least assist at teaching a course. By the way, I've been having this thought of maybe in the future releasing a logic, a type theory, very introductory type theory, logic, functional programming, dependent types kind of course later on in the future, like maybe later this year. If this is something you guys think would be interesting, let me know what are. Yeah, I'll probably release a form when I have a better idea of what's going on. But I have that goal to come up with a course, and this is one of the reasons why I'm reading these books. I want to understand what they cover, what they don't cover, and how can I. What is the gap, and what is the interest in the community around this stuff. As I said, I'm trying to make this a little more full time. I could be doing a job somewhere, like making quite some money. I've done some interesting jobs at some interesting companies at Bay Area, at Portland, at Galois. Like I've done some internships, some consulting. So I'm confident that I would be able to get quite an interesting job in this field. But I really feel that the best that I can do with my time right now is to be producing content for you guys. I really believe in this. I really want to make this work. I'm really happy to be here. So I'm counting on you guys to make this dream come true. Like let's make PL, let's make type theory more mainstream in some sense. It's kind of I don't know if you guys agree with me. I don't know if it's only me, but I feel like it's kind of really frustrating how in computer science right now all you talk is LLMs and machine learning and blah, 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 blah. And come on, there's so much beauty around type theory, around programming languages, around, like this is I feel like we touch kind of something more essential here in this kind of research, right? We touch the grounds of what it means for us to be doing computation, right? Yeah, chat's saying PL semantics, like type theory, PL semantics, this kind of stuff for sure. I agree. And it's really exciting, the purity on the knowledge and the stuff that we learn here. And I feel like everyone in this field, everyone around agrees with it. Like take Curry Howard isomorphism, for example, is one of the most beautiful things in math, in computer science. And you know a regular undergrad doesn't even know what it is. I know a lot of computer scientists doing PhDs that have never heard about Curry Howard isomorphism in their lives, and I find that, I mean, like, come on, it's so beautiful, it's so essential. Like the philosophically speaking, how computer science, math, and logic is the same thing. It's the same thing, right? It's just being smart enough, and how you just need a strong type system, and all of a sudden there's this whole new world being open for us. And I find that fascinating, incredible, absolutely beautiful, right? And I just love it. So I wanna make this a little more mainstream. That's why I'm here. That's why I'm doing this content. So I really, really appreciate any help, and if you guys can send this stuff to your friends, and like help us to build this community and to grow somehow, I would greatly appreciate it, because as I said, I wanna make this happen. This is my goal. Okay, so chat is saying here that there is so much work to do in this field, to bring the field to the work in programming. Yes. And I think I think right now we are in this. How can I say? We are um, we are right on the edge of being able to get these things to be more mainstream, right? Because we're starting to see a lot of mainstream programming languages to be receiving a lot more receiving to this functional programming ideas, right? Take TypeScript, for example. Take Python. Take Rust. Oh yeah, fuck. Take fucking Rust. Like Rust is really applying these ideas to the mainstream, and it's really exciting to me to see, like, that the community, that people, that um, the low level designers are starting to really appreciate the power and the necessity of type safety in their languages, in their programs. So this is, I personally believe that we are in this turning point of PL research to make these tools accessible to the everyday programmer. Like to take these things out of the academia, of the ivory tower of the academia. So I find it absolutely incredible, absolutely amazing, and this is what I believe to be the best for me to be working my time on right now. Um, a recent interview with Peter O'Hearn has him saying similar. Awesome. I have to. This reminds me that I have to invite him to the podcast as well, because I definitely want to be in conversation with AWS. So that would be nice. Rust is definitely the biggest example, with the Curry Howard isomorphism into linear logic. Yep. For sure, Ryan, for sure. Okay, so now that I've made clear how much of a fanboy I am of all this cool stuff that we work with, let's learn some lean. And oh yeah, and of course we cannot leave lean outside of this conversation itself, because that's the whole reason why lean exists, is because people were feeling that there is this really beautiful stuff that can assist us in doing mathematics, but it's we only kind of have academic tools. Rock is a kind of academic tool. It's made by researchers, kind of to researchers. And that's where Lean comes in and wanna kind of like break that pattern and make a real functional programming languages with dependent types. So that is also extremely, extremely exciting, which I love. And that's so yesterday. Okay. Yesterday. Oh no. Good thing that I came back because, well, not yesterday, Tuesday, God's sake. We finished talking about functions and definitions, and we have this file. We were working on this file, functions and definitions, and we finished that. Cool, cool, cool. Now let's create a new file to work on structures. And one thing that I'm gonna say is that so structures dot lean, cool. So okay. Okay, let's get started. Okay, so structures is the first step in writing a program. Oh yeah, one thing, what I was gonna say is that, I am going extremely slow. I'm not in a hurry, by no means. I'm here to have a good time, to give you guys some entertainment as well, to open room for some conversation. Like you guys talk. I can stop. We can just hang out and be talking about things, and let's go through the book. And I don't know any lean. I'm learning from zero, from scratch. If I used, I think Tuesday was I used the most lean in my life, and I'm very, very I'm loving the tool. I think it's really cool. There's incredible stuff going on, particularly in the points of usability. So yeah, that's cool. And okay, so let's learn a little bit about structures in Lean. First step in writing a program is usually to identify the problem domain's concepts, and then find suitable representation. Sometimes domain concept is a collection. Group the simple components together in a single package. Meaningful name. Okay, so that's a little introduction on how we're gonna do something similar to a record, I think. Defining structure introduces completely new type to Lean that can be reduced to any other type. This is useful. Multiple structures might represent different concepts, contain the same data. For instance, a point can be a couple of coordinates, floating points, whatever. Structure prevents API. Yeah. I think we all know this. So we continue using a couple of things for check 1.2. Oh yeah, before I forget, I always forget. I'm so bad doing this stuff. We are doing a crowdfunding event to take us to Zurich. If you guys would like to see TTForall creating content about the biggest Haskell event in the world, I would really appreciate if you guys could assist us taking us there. I need around $2,000. We have right now around $300 taken funded to take us there. So if you guys could assist with us, or even better, you can go to the marketplace and buy a bunch of stuff there. It would be really good too. So go to the not this one. TTForall, my Shopify, this marketplace, and buy a bunch of stuff. Buy like 10 shirts, 20 shirts. That would really, really, really assist the cause and help take us to Zurich. So greatly appreciate that. Okay, we have that 1.2, so it's going to be a float. What happens if I try to bring this to net? I can't. Okay, that's good. Check -454. Is that int? 0.21 something. Okay. Check 0.0. Yes, I will post this on YouTube. PK WOOK Carty. I don't know how to say your nickname. These are gonna definitely be going to YouTube. The Lean series will be on YouTube. They're being recorded, so this will live for the posterity. but the Software Foundation series are not. Those are gonna have solutions of a textbook, so we don't want to make those widely available. But yes, Lean series are gonna be on Discord. This is something that I find absolutely hideous in IEEE floating point numbers. Is it 454 or 545? I think it's 454, right? IEEE 454. Let's see. IEEE 454. Is it? What is it? 545? Not it? Floating point. What is the IEEE? 754. 754. Damn. This is a little beast from IEEE 754, which is we have -0. Yeah. Well, I did a project one time to formally verify floating point numbers using Coq at the time. I still have to get used to it. Change the name like that. And man, this floating points has so many corner cases. Like the more you dig into it, the worse it gets. I used to joke that I find it surprising that we were able to get to the moon and we still use floating point numbers because they're hideous. They're like, formally speaking, they're beasts. They're disgusting. But I have huge respect for the engineers who made that specification. So, because it is hard. It is hard to get floating point numbers right. Very hard. Okay. If I have decimal point, I'll win for float. But if I want to take 0 to float, then I have to annotate 0 to float. Someone in the chat saying that languages should have a fraction type as a primitive. Yeah. I agree. Or I think big nums sometimes. I don't know. I think the issue is that they're like you have to be able to talk about irrational numbers as well, and that's a hard problem because they're not a fraction, right? I don't know. Yeah, maintaining fractions as a primitive might be tricky, but I don't know. I'm not a language maintainer, so I have no idea. Maybe Ryan could chime in and talk about that in the chat. He is a language maintainer. Okay, let's write our first structure. Let's see here. Of course, our first structure is gonna be x and y, like float. Structure point where x is a float, y is a float, deriving wrapper. Okay, now we have declared point as a new structure. This deriving is saying that lean is going to generate the displays, going to be able to display. So I don't know, check point 1.2, 1.2. This is how you build a point. So yeah, we're gonna see this in the next line. Okay, I have to type it as a point. What is gonna go with this? Rand is saying that he has no clue how primitive fractions would be implemented. Well, okay, so have a definition. Oh yeah, I wanted to say if I could show it, because wrapper is telling how we can show this. like how the interpreter is gonna show that. It's gonna output that. That's what the deriving is doing. So x is 0, 0. I think if I put just 0 here, it should be fine, right? Because it already knows that x must be a float. Yeah. So eval origin. Now give me that. I would expect. Okay. And if I don't, if I get rid of this, then this eval fails. Yes. What is this? Does it add the deriving implicitly somehow? When eval origin. Yeah, I think this is not true anymore. Because if I once I take this out, then this line should fail. This is what it's saying. So maybe this is not true anymore. Unless I did something wrong. Because I don't know. Well, if I change here, this will change, right? Yeah, like it's instant. Yeah. So yeah. So I don't think this is true anymore. This message is saying that evaluation doesn't communicate. This is a tricky thing about textbooks, right? Especially textbooks that is made as a form of documentation for the language. It's because as the language evolves, these little things change, right? And you have to update the book. And the language is evolving very, very fast. So it's tricky to keep it updated, I think. So with the deriving, eval origin looks the same. Are we? Oh, yeah. I think chat was not showing up here. Okay, yeah, here it is. Chat is definitely showing up. Okay, I recall fixing a bug in the lab. Oh God, we have someone polluting the chat. Get out of here, you polluter of the chat. Not you, Shexer. So Shexer recalls fixing a bug in the library for concurrency types. The algorithms are related to primitive things in a computer, which is probably why they're not a primitive. It was a lot of manual arithmetic implementation that would probably need to be done for fraction types also. Yeah. I think that the hard part is that. Oh.
Davaclavo just followed.
Yeah, thanks for the follow and welcome. Welcome. I think that the hard part about adding something as a primitive to a language is that as the language evolves, the new features will interact with that primitive, right? So the more things that we have as a primitive, the harder it gets for you to maintain your language, because it adds an exponential factor of complexity to grow the language, right? Adding two fractions would need to be implemented by the compiler. Not sure how it affects the type system. Yeah, I don't know. Yeah, exactly. I don't know. There's definitely there definitely must be research about fraction types in programming languages. I mean, it's so kind of like so normal, such a normal thing to expect in a language, right? I'll either that or it would be or people, like there are some results in our field that people just say, "Oh, this is kind of like trivial. We know how to do this for a thousand years," and nobody takes the time to actually write it down how it's done. So it's kind of like part of the folklore. That's what it means to be part of the folklore, is because it's not published anywhere, but the community knows pretty well how to do it. So maybe that's part of the folklore. I don't know, and it's fine. It's fine to sidetrack me from Lean. Um, we are here to hang out. So, I love talking, just hanging out, talking about this stuff. So no worries. You guys make me company for my lonely afternoons. I have a lot of fun doing this kind of stuff. So um, okay, yeah, let's go back here. We are eval origin. Cool, cool, cool. And now it's showing how to project things from a record. That's useful. I wonder if you can do something like this, and then dot x, or something like this, I guess. Okay. Is there like is it how you do let bindings? Type point. Didn't learn this yet, but I'm just curious now. In a.x, I guess. What is the syntax for let? I don't know. That's what I would expect. Sure, we're gonna learn eventually. Okay, so at points. Okay. I was very tempted to just copy this definition, but that would be cheating. Let's take our time. If you take your time to write down every single definition, you actually pay more attention to what you're writing. So if there's something interesting going on, you actually pay more attention to how things go. Dot by plus p2 dot by. I think what I would expect is actually like write something more like this. Usually, oh, yeah. It's kind of really small, so it doesn't really matter. Okay, now we calculate the distance by taking square roots. Okay. Oh, that's why we're using floating points, because they want to calculate the distance. Otherwise, it would be pretty imprecise. Square root p2 dot x minus p1 dot x plus p2 dot y minus p1 dot y to the power of 2. Now we can do the distance of x 1.0, y 2.0, x 5.0, y minus 1.0. And we get 5. I have no idea if it should be 5, but if the book's saying it's 5, I'll believe it. The formula is right. 3D point. I'm getting bored with this structure. 0.3D. Our conversation about fractions was more interesting. Y float, Z float. This is why it's good to read this book in a stream, because I force myself to go through the boring parts. Otherwise, I'll just keep through all of this. I wouldn't care. Because I'm sure at some point there will be something that will be interesting, but if I was just skipping, I wouldn't pay attention really. Yeah, yeah, thanks. 0 z 0. Okay. Uh-huh. This means that the structure expected type must be known in order to use the curly brace syntax. If the type is not known, Lean will not be able to instantiate the structure. For example, yeah, this 0 0 y 0 0 would be an error. So it should do. Yeah, can I do this to be a 3D point? No, you cannot, because you need to add the z. Okay. It's not known. Fusion situation can be rounded by adding notation. We did that. Oh, updating. Cool. This is interesting. Okay. Imagine I have a 0x that replaces whatever with 0. Most of the sentence would mean that memory location is overwritten. By the way, I want to mention that the problem of adding records to a language is less trivial than you would expect. Like making records a primitive of your language is more tricky than you think because of issues about updating, and most importantly about, I think it's called eta expansion, which if I remember correctly, it's things related to I've dealt with this at one point in a project that I was working. Trying to remember the tricky parts. I remember it's you stumble upon some tricky meta theoretical problems to guarantee safety of your stuff very quick when you are adding records to your language. So you have to make some design choices about this to make sure that things are gonna behave as you expect. Don't remember now the details, but it also touches problems around similar problems as module systems in your language. Those are much less trivial than one would expect. And what Rock does is that Rock does not add records to as primitive. Rock does not have records as primitives. Records in Rock is just they're all inductive data types. They're inductive data types, and the front end adds a nice syntax sugar to generate the data types for you. So especially when you're dealing with things like recursion inside your record, then things start getting tricky because now you need the induction scheme, right? So Rock just go ahead and doesn't deal with any of that because it doesn't have records. Records just a syntax sugar and generate inductive data types under the hood. And because of that design choice, there are certain things that you would expect you would be able to do with records that you're not able to because it's not a primitive. I forgot the exact examples of those things that I'm mentioning, but I'm saying all of this as a question of is records a primitive in Lean or not? So if you know the answer to that question, please let me know in the comments. Like if you're on YouTube or if you are in the chat right now, I'd love to know that. That must be an interesting thing. Okay, so it's saying that function programming languages, we don't usually we don't change the value of anything. So when you say that you're changing the value of a record, what we're doing, you're actually creating a new record. Ask an AI, is Lean records a primitive or not? Let me know what ChatGPT says. I wouldn't entirely trust that though. I wouldn't trust. You know, it could say anything, and I would believe at that point. Um, if you go to ChatGPT and you send the actual link to the current representation of records and ask it, is it a primitive? I don't know, like a link to the GitHub of where these things are implemented, and ask, hey, can you check this GitHub and tell me if it's primitive or not? Then I would believe a little more, quite more. Yay, team Lean Stream. Welcome to the Twitch log sub. So Claude's saying that records are not a primitive in Lean, and we don't believe. Okay, let's compare. Let's compare. Ask ChatGPT now, and then ask Gemini. Let's see. Let's put them to compete. Okay. My coffee is getting cold. Some people like cold coffee, but I don't know, it's different. Okay, so what is most always meant by this kind of statements that a fresh point is allocated, and then x is pointing to a new value, and then all the fields are pointing to the original value from the input. One way to write it down is manually transferring y. 0x. 0x is a point and point. Well, that's a good point. Oh man, but I don't know. Espressos, they're just so condensed. Like it's just like it's like you know how pinchers are really small, and you condense all those anger in a very small little creature and make this really angry little creature. Espresso is like that, but with caffeine, right? Like just condense this huge amount of energy in espresso, and you drink it really quick, and you're like, right? Espresso shots for you, man. Okay, so let's see. Origin. Okay, my origin. Let me change my origin here to 1, and let's see what happens if I do 0x origin. 0x origin. Okay, nice, it's working. Okay. Oh, I'll leave this risk contain multiple fields with the same type. Then it would be risk to copy paste, blah blah. So what we can do is to change it more directly with p with x0. Okay, that's nice. That's nice to have. Remember that the structure of the syntax does not modify existing value. It creates new values that share some fields with old values, given the point 4 and 3. Okay. F4 and 3 point. I find it a little annoying that when I hit enter here, it doesn't automatically tab for me. I wonder if it's my VS Code I should look at for this. Okay, so 9.2 in Lean 9.2, the doc says that the record is a syntax trigger. Let's take a look at that. Thanks for pointing that out, man. Let's take a look at it. Actually, I'm pretty curious about it. Sugar, not sugar. Primitive maybe. Okay. Active types. Moreover, noted that remarkable fact that possible to construct substantial edifice. Blah blah blah. Yeah. Oh. Yeah. So it's saying that Lean really doesn't doesn't add more stuff there. Oh, so the record is actually non-recursive. So it is a non-recursive data type, and that actually simplified the generation of the induction schemes. Okay, nice. Type. Oh, product types structure. Okay. Mathematics, not uncommon to define structures contain many fields. Yeah. Okay, let's see 9.2 that was pointed. Structures to create this stuff of mathematics. Structure name dot or field name. Oh, this is nice. This is a nice syntax. Huh. Let me use it. I think we can use it here. Yeah, here. Point. No? Wait. It's not working though. Expected types not known. What is the difference between this and that? Why does this one have 2 columns? And this one? What happened? I'm so confused. This doesn't work. Didn't work at least. Or something that I might be missing. So there should be some. I have no idea. Pretty hot in here. Let me reduce the AC a little more. Specify that assigned fields, specification of record, hire by. Yeah, I don't even know what reduce is. In any case, yeah. Here, the structure is essentially a front end for defined inductive types. Introduce a new namespace with the same name. General form follows the following. Again, why does it use double semicolon? Are we in the right documentation? I don't know. I trust my chat. Yeah, I will stick to the book. This is what I was looking for. This exact phrase here, that is essentially a front end for defining inductive type. So exactly the same thing. I don't know. Maybe this is Lean4, but this is leanprover.github.io. So this is exactly the same site we're at, right? And I think you just click here, I guess, right? Where are structures? There are no search? This is not searchable? Oh, here it is. Reference. Not structure. Structures. Structure. No. Wait, what? What is going on here? I don't want modules. I want structures. Quotients. Why is it calling this structure? So that other one that we were looking at, that was Lean4. Man. Structure. Control structure, structure instance, structure declaration. I think this one. Inductive types, yes. Yes, here we are. Fields, example. Yeah. Now it's making a little more sense. Yep, this one. It's fine. Yeah, this is what we were looking for. This one. Okay. I mean, Lean4 is already 2 years old by now. It's not that recent. It's just somewhat recent. Okay, so okay. Let me just confirm if it's still syntax sugar. That's the header structure declaration. Structures are inductive types that have only one single constructor and no indices. Generates codes for structures that offer a number of coordinates. Projection. Constructor syntax on the field rather than a positional argument. That's nice. Similar syntax may be used to replace the values of certain fields. May extend, and structures may extend other structures. Structures may be recursive. They are subject to same restrictions regarding strict positivity. Structures do not add any expressive partially. All of the features are implemented in current self-term generation. Yep. Same thing. It's not a primitive. That's what I wanted to know. Okay. No, you're fine. I'm not. No, yeah, we're not Lean users here. Don't worry. We are here to learn together. Learning Lean together. Slowly. Very slowly. Okay, 4 and 3. Yep, let's bump this a little bit. 4.3. Y 3.4. Eval 4 and 3. Okay. 0x eval 0x 4. Do you think Lean4 instead of eval it used reduce? That's why we're seeing reduce there instead of eval. Was that it? Because I just got curious. I wanna see this reduce now. I wanna know the difference. Is it like this is a beta reduction? Is it a CBN versus CBV kind of thing? I don't know. That'd be fun. Okay. Let's see. Behind the scenes. Okay. One consequence of the fact that structure updates. Getting some sweet here. Consequence of the fact that structure updates do not modify the original structures, that it becomes easier to reason about cases where the new value is computed from the old one. New values are provided. Okay. Every structure has a constructor. Some constructor may source confusion. Okay, he's gonna talk about what constructors actually are. Okay, so this is what I was looking for somewhere here. Mm, yeah, I think I was looking for what is the syntax, because originally I was trying to do this, right? Point 1.2 1.2. So the syntax is .mk to make the syntax. So it comes with one constructor. Okay. Um, oh. Oh, look, same thing as last time. If I do not put the parentheses, then it shows the arguments in here as if it's a function. It's a function. With parentheses, it becomes the little nice arrows. Oh, here's the two columns. Look at that. Look at that. Okay. Wait, what? Oh. Huh. What a weird syntax, man. So this changes the name of the constructor of the structure. What happens when I... Okay. But now I'm trying to shadow this declaration, which didn't complain. So let's do a point prime. And now I can check point prime dot point. Okay. What happens if I try to use MK now? It really doesn't exist anymore. That's awesome. Yeah, good question. Does it allow multiple constructors? Point prime. I think the answer is no, unless it's a different thing. Let's take a look again at the reference. There is the extension. Oh, here, declaration modifier ident, but only one ident here. Let's see. Multiple times. Oh no, the question mark is it can be present or not. So it can only be one. Yeah, from this syntax, it can only be one. That should be your answer. Otherwise, it would be star instead of the question mark. Okay. And then I have the accessor for X and accessor for Y. Same self. Cool. Cool. Some OO for you. Wonder if... Cool. Like just curly braces, structure, converted behind the scene, the syntax, the prior definition of at points converted to call, accessor, all points, original both yield 0. Wait, wait. Oh. Cool. Cool. Okay. So this is just a function call like this. Yep. Which makes sense. It's what I would expect, really. Eval origin.x equals point x origin. Accessor dot notation is usable with more than just structure fields. Can be used functions, any names, arguments. The function name TF is called. Becomes left. It's leftmost argument of type T. Hang on, I got completely sidetracked in my head. I literally did not understand a word of what I just read. This has also happened with you guys. I was in a completely different universe in my head right now. Okay, so the dot notation is usable with more than just structure fields. Must be used for functions that take any number of arguments. Okay. Notation has the form. Provided in order to remain arguments, for instance. This is very interesting. This is a very nice to have feature in the front end of a language. This makes things so feels so natural, right? This is something we don't usually get from a functional programming language. I'm curious with I wanted to be able to print string. How do I do that? Ha. Okay. So strings a structure with one element that is a data as a list of chars. How do I print the functions that implement string? Where is append, and how does it know that that string.append is a function? I would expect that this is a an instance. This is a type class. That would be my guess. But I would be curious. I want to see all of the functions related to string, or everything that I can do string dot something. I'd like to figure out how to do that. Browse the docs. I don't understand completely, but Lean4 has both reduce and eval. Reduce uses kernel reduction rules only, whereas eval uses the bytecode interpreter. This means that I/O is only executed when using eval. Let's see. Well, that's an answer. There's an answer. This is an answer, but this is an answer. I think it makes sense what I just said. Reduce uses kernel reduction only, so we can see here how some things were not reduced, just unfolded and open certain things. And if I'll take care of everything, I guess. But yeah, I'll leave this question behind. How do I print all functions that string implements? Let's say let's string implements. This is how implements. This is how you would word it in an OO style programming language, right? String is implementing this bunch of stuff. So this is my question. How do I find those? Okay. The function point.modify both, that is modify both, find the point namespace, applies a function to both fields and in a point. Point arguments comes after the function argument. It can be used without notation. Def point. Oh. Oh. There's something related to a namespace. I don't know C++ to understand namespaces. And what is its relationship with type classes? Because Lean now is giving the vibes that it has both, right? Man, Leo is crazy because this is definitely C++ stuff. Damn, let's see. Yeah, I agree. It is amazing. P is a point. Is a point. X. Okay, applies F to P of X. Oh, this is a function application. Cool. Even though the point argument comes after the function argument, it can be used with dot notation as well. I love how sneaky David is, because he is sneaking in some, how's it called, primitives for float here and there without saying anything, like very, very gentle, like don't even notice, but he's teaching you something like, oh, now you know that float has this other thing now. That's nice. 4 and 3 dot modify both. Float.4. But then, even though point argument comes, well, you need modify both. But then again, wait. Oh, okay, 4 and 3. Floor. Now I'm starting to get curious a little bit, because I think the next thing we should see at some point is that you can build records on top of other records, kind of thing, like some inheritance or interfacing somehow, I guess. So does it also inherits all these functions in this namespace? I'm curious about that now. How that's gonna go? Represent 4 and 3, with arg1 being float.floor. I don't like this syntax. This made me confused, because I'm applying this function to these two arguments, right? Because this is a function from to 4 and 3, like from point. Yeah, this is not functional anymore. Like the way you usually think about function as being functional programming, right? Like you have the function and you're applying the arguments. But now this is OO with the method where you have the object and you're calling the method of this object with this thing. I feel weird about it. It's cool for sure because now it's weird. I think it requires some getting used to. I find it weird. It's cool, but this is weird. Like this call, I find it weird. Type matches, not necessarily the first. This is because, yeah. Okay. All right. Rectangular prism that contains the height, width, and depth. Oh, okay. Same as the last, like what we did in functs and defs, but now with a structure. Rectangular prism. Wait, what is this? What is this? Structure where? Ah. Okay. Wonder why. That's an interesting choice. Wonder why. Okay, so height. So that it is time to close the book on Lean4. So weird that it is time to close the book. I didn't understand. I didn't understand what we're talking about. Float. Okay, and then I have width, float, and depth. Float. Deriving wrapper. I was gonna say show. That's how you say it in Haskell, I think. Okay, now function def volume that takes rectangular prism and returns a float. Cool. Wait, no. It's not even what I want though. This is what I want. Okay. Okay, so I'll go to the definition that I got from last time, which is this one. Just multiply the whole thing. Okay, so r dot height times r dot width times r dot depth. Oop. I always got this wrong. Is this right though? Yeah, the H is before the T. Okay. What if I do rectangular prism dot volume? And I think I can do now, well, def my rec, my rec, which is a rectangular prism, and I have height being 1, width being 2, and depth being 5. And I eval my rec dot volume. Nice. This is cool. This is pretty cool. Alright. But again, this is OO, man. This is wrong. No, thanks. Yeah, the syntax there. I mean, so what I was saying that time is that like I tried this one because this is what I would expect, because def, like that's how you do defs and things like that, or use triple camo, you do this all the time, right? But then this is saying that this is deprecated, right? So it used to be like this, and they willingly came up with a decision that they prefer where instead of colon and equal. Like for some reason they were fine with that before, and something happened somewhere along the way. They're like, no, this is bad. This is good. That's what I think it's weird. The decision along the way, like just that very minor change, and that makes me curious what happened. And too many cooks in the kitchen, is that an expression to mean that everyone kind of like have a different preference on things, and they're gonna change? I don't know. Is that what it means? Then a structure called segment. Segment. Oh, structure. Structure segment. Where? Bytes and points. Well, so you need x being a point and y being a point. Well, I think like L1, no, well, P1 and P2, I guess. Wait. Oh. Huh. Isn't that something? So what happened here is that, remember how I had commented out the deriving wrapper for point, because it wasn't like the book was saying that eval should kind of like fail to show the point without this deriving. So I left it commented out, but now to derive the segment, it's complaining that I do not have representation like wrapper for point. So I'm like, that's weird. So I uncommented and problem solved. So I think somewhere along the way, eval doesn't really need to use wrapper anymore, or I don't know. But definitely, so wrapper definitely was not implemented, is not implemented without this deriving, I guess. Weird as well. Okay, so define a function, def. I'll do the same thing, segment dot length. Why the h in length comes after the t, but in height it comes before? English. Just make me confused. I don't like it. Okay, so it takes the segment and returns a float. And I had distance somewhere, right? What was it? Distance. Here you are, distance. Okay. So I can do distance s.p1, s.p2. Okay, good. I should have at most two fields. Yeah. Which names are introduced declaration? Which names are introduced by the declaration rectangular prism? Height, width, and depth. Which names are introduced by the following declaration: hamster and book? What are their types? Hamster introduce name and fluffy. Name is string, fluffy is a bool. I think that's the question, right? What are their types? Hamster is a type, I guess, right? Oh, duh. Yeah. So record is a type. Then book has a constructor called myBook with declarations with the fields being title, author, and price. All right, we finished one more chapter of the book. This is exciting. And then data types. Guys, I'm gonna finish this stream here today because I absolutely fucking love algebraic data types. That was the whole thing of my research, doing what was a PhD and became a master's later. It's all about data types. So I'm very confident. That's one thing that I'm confident about. My knowledge is my knowledge on data types. I have thoughts. I have a fairly strong understanding of how data types work under the hood in Rock. So I really wanna take my time in this chapter, like go really in depth and understanding and having some thoughts and making some differences on how, like the differences between Rock and Lean here, and my expectations and my thoughts and my opinions as well, because this really is the crux. This is the heart of dependent types, like of interactive theorem provers, lies on algebraic data types. I argue that data types is the heart of functional programming as well. Exactly because how pattern matching is. Someone is asking, how should I say your name here? Shexer, Chexer. So someone is asking in the chat what is the coffee that I was drinking. Let me show you. Actually. So the coffee that I drink is Dolce Gusto, and I just use capsules. Some people hate capsules. This is a minor brand of Nescafe, which they have a lot more capsules on the actual Nescafe machine. But I want to buy a Nescafe machine. I really like capsules. Like, you get really used to it. For me, it's a pretty high quality coffee. Some people might disagree, but at least it's not Keurig. Americans have these machines called Keurig at their houses, and I find that absolutely disgusting coffee. in the US, kind of like a lot of the hotels have these machines in the hotel. I mean, if you don't have any coffee around, it does the deal, but it's pretty bad. Keurig is pretty bad. Yeah, I have a mocha pot. You can do pretty solid coffee with it. I've tried doing some mocha in the past, but I usually burn the coffee. I don't know, I don't know if my mocha was bad, low quality. I don't know if my coffee wasn't grinded. I never know if it's ground or grounded. But I don't know if the coffee was in the proper consistency. Like something was going wrong along the way. It's a lot of effort. The good thing about this capsule is just buy them, put in there, and you're drinking pretty fast. But honestly, I've been thinking about reducing my coffee consumption more. I have this policy where I only drink three cups a day of these capsules, and it's good for me, I guess. But I don't know, being really considering to drop it altogether, because in the end of the day, it's just it's an addiction. Like, we are addicted to caffeine, we don't need it, and we convince ourselves that we do. But this hate that you get from like being so nice to have in the morning, that is the addiction talking. So I don't know. I don't know if I really want that for the rest of my life. It's not doesn't mean it's good for me. I've been having some progress like in meditation, and I started noticing how much it affects my body. Like the heart race and the anxiety that comes along with it. Like sometimes it's very minor, but sometimes it's considerate. And most of the time we just kind of like ignore it. I think it's something else, but often it's just a caffeine, which kind of, you know. But yeah, well, life's about decisions. What are the decisions we are able to to afford in our points in life. Like you have to be wise about them. You have half a cup of espresso per day. That's impressive because a cup of espresso is really small. But yeah, that's really a hit of caffeine. So another Ryan, welcome. This was our first time chatting. The other Ryan, that famous type theorist Sanka reduction. I don't know. I don't think I got the reference. I don't know what Sanka is. Sorry about that. Sorry about that. So what I was saying before going into this coffee tangent is that yeah, I wanna take my time in algebraic data types because this is the heart of how we do proofs in dependently typed programming because the most important thing in this yeah, I'm gonna say the most important thing in this independently typed programming is the derivation of induction. And derivation of induction is something that goes hand in hand, attached to is deeply attached to how you implement your data types and what are the rules around algebraic data types. I I expect that Lean will follow the same things that Rock follows because because the because it's where this the notion like doing data types right has been thought the most. If you go back to the research of how algebraic data types work in a dependently typed setting, which we usually call inductive definitions or inductive families. There it goes by a couple of names. Like dependently typed data types, inductive definitions, inductive families. You'll find these three names. You'll probably find other names for this. But if you really go back in the history of the research, Coq's fathers, like especially Coquin, um, yeah, Coquin, Andres Abel has put a lot of thought into how to do these inductive data types correct, and it's hard. It's really hard. It's really hard. Okay, so I wanna go slow in this book, try to find an understanding and see if it matches my expectations and my biases. Even I don't know. As I said, I've read a bunch of those papers. I even talked with Coquin himself about this kind of stuff, and and he agrees. Coquin is kind of like Coquin and Isabel. They're kind of the fathers of implementing algebraic data types correctly in a dependently type setting, and it is kind of broken. It's weird, like it is kind of broken, right? Because there are so many little, very, very, very minute details of things that can and will break under the hood for very, very subtle problems, right? So that's why I was saying how in rock you have a lot of dependent pattern matching is in order to be able to reason about the dependent types in algebraic data types, right? And in Agda, you don't need that many tactics because the algorithm on how to deal with those things is a little better in Agda. This is due to Jasper Cox. Jasper Cox have an amazing PhD thesis working with Andres Abel in Agda to develop an algorithm to better perform dependently typed dependent types, dependently, well, dependent pattern match, right? So his whole research is how to do dependent pattern match right, better, and in the context of intuitionistic type theory, without relying on some extra axioms in Coq. Because before, what Agda would do, they would have this extra axiom called K, and I would have to reveal my knowledge on this now. It might be the case that Lean doesn't need this K axiom because of its classics setting that it works with. Yeah. It is. It is extremely deep. It is extremely deep, and there's a lot of stuff going on here, and it's very. This is the heart of dependently typed programming languages. I'll say it very confidently that data types are the heart of functional programming and all of that. A lot of times it's even frustrating. You find it kind of hard, like there, and it's kind of like it's an open field. Okay, when you start going into homotopy type theory, like a lot of what homotopy type theory is doing is fixing the issues that were left behind in dependently typed programming languages data types because of how equality is handled many times. Okay, so a lot of what homotopy type theory is doing is finishing the research on how algebraic data types are done. Okay, and it's hard. There's a lot going on in there. There is, and it's very tricky, and it's because of all this trickiness that you get the proof power of induction. Okay, because if you think about it, what these languages are doing, it has to be recursive, right? But how do you do recursion, but at the same time you keep things sound, type sound, in the presence of recursion. So you have to rule out things that doesn't terminate. And in order to do that, you have to apply restrictions to your data types because the shape of your data types is gonna say what is the shape of your recursion, right? So you also have to apply restrictions on how your functions are doing their recursive calls in their data types, and it's really, there's a really nice line of research that Aaron Stupp has been leading with his theorem prover called Cedil, where they solve this problem by not adding data types at all in their language, which is absolutely incredible. So they don't have algebraic data types as a primitive in their calculus, and that is very surprising because in their language, Cedil, their algebraic data types is just a syntax sugar. All of the inductive data types, definitions, and induction schemes, they're all generated under the hood by the compiler. And that was Krista's Jenkins PhD thesis, just generating that whole thing. And it's really, really impressive, really cool stuff going on. So again, this is still an open line of research. There is very cool stuff going on in this, and it is extremely, extremely hard, I want to say. I try to understand Krista's Jenkins PhD thesis, and whew, man, to make those generations. Anyways, I'm just giving you a little bit of a taste of the things that we can touch and talk next Tuesday, and I might prepare some things to show to you guys depending on your interest. Like show a little bit of Cedil, maybe show a little bit of Agda. Another thing that I was going to mention is how, like I was saying, how Agda has a better dependent pattern matching algorithm than Rock. Rock's developers actually went ahead and I'm gonna say stole, but we don't steal things in our community. We humbly, like take the good ideas and we implement them in different places by saying where it came from, giving proper credit. And Matthieu Suzeau, which is another beast in our field. he's the guy who implements most of the stuff in Rock these days. Him and Pierre Marie, they're incredible. And so Matheus Suzo, he re-implemented all of Jasper Coq's PhD thesis, compiling dependent pattern matching without K in Rock, and made this plugin called Equations, and that completely changes how Rock does dependent pattern matching. And a lot of people are kind of like, it's common for you to use that kind of pattern matching again, but I don't like it because it's those pattern match. There's two kinds of pattern matching, right? The kind like Haskell style or OCaml style. Haskell style, you have those equations, right? You have like my func with type X, and then here you have my func that takes like, I don't know, like A of type U, or A of type A or something, and returns something of type X, right? And then here you have this ugh, you have like your argument here, and then you have an equation, right? This is how you do in Haskell. And in OCaml, you would have like def, my function, or something like this, right? And then you have like your argument here, and the return here. But then you have like match something, like match A with something, right? And I think this style of pattern matching is the right way to do pattern matching, because this one, it's kind of like, so this, your pattern matching is an expression, right? This one, your pattern matching is not an expression. So in order to do another pattern match, you need another name for doing the same thing here with a case here, and this is like, you have two syntax here to do this exactly the same thing. I think it's kind of broken. I don't like it. This is a personal preference of mine. But anyway, so dependent data types, pattern matching, and recursive functions definitions, all of this is they go hand in hand. They're all the same thing. They're all rotating around the same stuff. So yeah, that's a little taste of what we might have. Tuesday, when I'll go and learn, we're gonna learn all about Lean's data types, which is, I'm excited. So I'm gonna stay here. I'm gonna finish by giving the final spiels and selling the stuff. We're trying to raise some funds, and we're counting on you guys to assist us to get to Zurich, the biggest Haskell event. That's funny, right? Like I just chat on Haskell syntax, and I'm saying, oh, I mean, we're going to the biggest Haskell event, right? But yes, we want to go to Zurich, and we're making accommodations to make that happen, and we are counting on you guys' assistance to help to take us there, to make even more content for you guys. We're planning on doing some panels, some roundtables, interviewing people during that conference, like making Twitter posts, all those cool things to like bring the conference for people who are not able to be there physically. I'm working together with the organizers, especially Farhad, which invited me there. He's a listener of the podcast, which really warms my heart. So if you guys could assist us to make that happen, we would really greatly appreciate. Go to Ko-Fi/TTForall, and any kind of donation will be greatly appreciated. Or even better, well, I mean, donation is really good. It's really awesome. Or go to my Shopify. We have this brand new marketplace running, and if you could, anything that you buy here will be a great assistance for our podcast, for the stuff that we're doing. As I've mentioned before, I'm trying to make this financially viable for me to spend as much time making content in PL and type theory just for you guys. So check out our Shopify. Here we have some really cool shirts, like well-typed programs cannot go wrong, or some cool names, friend style, with the logical legends, and we have this hoodie here with the lambda cube in the back, which I find really cool. So go to the Shopify, and you can assist us by buying the products there. Make sure to check the link in the description when this is on YouTube. You might have a discount code that I put there just for you guys. So that's it. Did I forget anything? Yeah, don't forget to go to TTForall. We have a podcast with 50 episodes of content, more almost like 90 hours of content of amazing PL stuff happening. We just started. Last episode was the first episode that we actually have video. We can actually see people in there talking. That's Ryan Brewer, and we were talking on how he learned all of this stuff on his own, and he's really cool, really cool. Anyway, so yeah, I think that's it. Staying here. Take care of you guys. See you guys tomorrow. Well, no, not tomorrow. Not tomorrow. It's Friday. So next Monday, we're gonna continue our study group on software foundation. Not a study group, more as a speed run. So see you guys there. Take care. Thanks for being here. Bye bye.